All right, Chapter 9, Section 9.1, Valence electrons. We touched on this a little bit in Chapter 8. Now we're going all in on it. Okay, valence electrons, what are they? Now, valence electrons need to be distinguished from your so-called core electrons. The valence electrons are your outermost electrons. And what you're going to see is that there's some trends that you can kind of follow across the periodic table. The electron configurations of group 1a metals contain one electron in their outer s orbital. So those outermost electrons are in that s orbital for group 1. Okay, group 2 metals have two electrons in their outermost orbital, and that happens to be an s orbital. All electrons that are not valence electrons are core electrons. So it's kind of simple. It's an electron, or electrons are either valence electrons or core electrons. The end. All right, valence electrons in main group elements are in the highest occupied energy level, the principal quantum number, n. Valence electrons are involved in bonding. So in the event that you share an electron or you transfer an electron, it's going to be a valence electron that is shared or transferred between atoms. So elements with the same valence electron configurations have similar chemical properties. The number of valence electrons in main group elements is equal to their group number, or their A group number. So if you look on the periodic table, you'll see 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. That's what you can kind of reference. And you'll see that here on the periodic table. So we've got 1A, 2A, 3 through 8A, and the number of valence electrons for each of these different species. So lead, for instance, is right here. Lead has 4 valence electrons. Okay, so that's kind of a good trend that you can that you can think about. So this example tells us to write the electron configurations and determine the number of valence electrons for oxygen, sulfur, tellurium, and selenium. And then it asks us what feature makes them have very similar chemical properties. One thing that we just learned was that if we have the same number of valence electrons or the same valence electron configuration, elements are going to be fairly similar to one another. So you can see here the periodic table, and what I'm going to do is I'm going to select the atoms that we want to compare. We want to compare oxygen and sulfur. We want to look at selenium, and we want to look at tellurium. Now, this tells us to write the electron configurations. What I want to do is I want to go ahead and practice writing my condensed electron configurations. So for oxygen, I want to put my nearest preceding noble gas, which is helium. I'm going to put He, and then I'll put 2s2, 2p4. Okay. Then my next atom is sulfur, which I will use Ne as my nearest preceding noble gas. I will say 3s2 and 3p4. Next up would be selenium, which my nearest noble gas is going to be Ar. Bracket that, and then go ahead and put in 4s2. And since selenium is here, I've got to take into consideration all these guys. 4s2, 3d10, and 4p4. Okay, my last one is going to be tellurium, and my nearest noble gas, preceding noble gas, is going to be krypton. I've got 5s2, 4d10, and 5p4. Okay, so there's my condensed electron configuration. This question asks for electron configurations, but I wanted to practice that condensed electron configuration. So I also saved myself some time and stress on that. Now, what feature makes them very similar or have similar chemical properties? Well, I've got an NS2 and an NP4. The exact same configuration or valence electron configuration in my S and P subshells. That's what makes them similar to one another. Now, this asks me to determine the number of valence electrons of sodium and chlorine. Okay, well, I'll tell you, sodium is in group 1. So 1 VE, 1 valence electron. Chlorine is in group 7A, and it's got 7 valence electrons. All right. Well, that's kind of it. I mean, lots of this valence electron stuff, it really isn't very difficult. It's just a matter of finding it on the periodic table. I hope this is helpful. You got this. The better understanding you have of electron configuration, the easier that this is going to be. But let's rock and roll.